Thank you.
I will talk about some health relevant topic based on my work, which is empathetic dialogue generation and graph reasoning to support mental health and disease diagnosis. So, before I start to introduce my work, and I would like to give the brief introduction. So, I graduated from Shanghai University with bachelor engineering degrees in 2017, and then I studied my PhD at the University of Sheffield. Then I started my postdoc at the Center of AI in the UCL, working with Professor Emily. And currently, I'm the lecturer at the Department of Computing Science and South China Normal University Joint Institute at the University of Aberdeen. So, my research mainly focuses on natural language processing, natural language generation, and machine learning. And especially, I focus on dialogue system and multimodality NLP applications. Some machine learning areas, for example, expandable AI, deep latent variable models, and knowledge graphs. So today I would like to talk about two related work, two my works relevant to the health topic. So the first is effective decoding for empathetic response generation, and second is the disease diagnosis using large language models and graph reasoning. So my first work that was collaborated with the Ullage University and the University of Sheffield. So actually, understanding speakers' feeling and produce like appropriate responses with emotion connections. Actually, it's a key communication skill for empathetic dialogue systems. And it's also believed by most people to be very crucial for many service-oriented applications, such as mental health interventions, assisting medical diagnosis, or restaurant or hotel booking systems. So, in order to better understand a speaker or listener's feeling and to be more empathetic, we actually need to place ourselves into the partner's position. And based on this, an empathetic dialogue system needs to understand the situation of speaker and also needs to understand the emotion state of the speaker. And let's look at these two examples. If the dialogue system only produces a general or plain response to the speaker when the speaker is feeling sad or happy, it can't effectively, move the conversation forward. Instead, the listener responds with feeling of sorry or proud regarding to speaker's emotion state, which could support speaker's mental state and move the conversation forward easily. And based on this hypothesis, we propose an effective decoding model for the empathetic response generation, and which was published in IMG 2021. Um, in our work, we mainly use a public data set, which is called empathetic dialogue. And this is the open domain one-on-one conversation. And this data set contains 32 emotion labels. And you could have the general overview about those labels and most used words from speakers and listeners on the right-hand side. So this is the framework of our proposed model, and we mainly construct our model based on a pre-trained language model, and then we further consider the emotion state either from speakers or listeners, and finally we generate the empathetic responses based on the roles from speakers and listeners, and also based on the emotion state from both sides. And then we compared our model with several strong baselines, and most of them used use the pre-trained language model as the backbone, and then we compare from using the automatic evaluation metric and also human evaluation. So there were some interesting findings when we compare our model with the baselines. And we randomly sample 50 single-tier and 50 multi-tier dialogues and ask two PhD students from computer science to detect which model is better in terms of empathetic responding, or there is no any difference. So on the average, 48% generated empathetic responses from our model are preferred by two human readers compared to other baselines. And also based on the human evaluation, our model outperforms our other baselines regarding empathy, relevance, and fluency of the generated responses. And for each emotion label, and we actually retrieve the nearest neighbor words from the speaker and listeners' point of view. And we found actually some interesting examples. And for example, take the emotion label proud as an example. And the words like proud, happy, honor in the speaker space are very close semantically and are highly relevant to the emotion label. Also, the words like son, daughter often be mentioned in parents' expression of pride. And then in the listener space, words like congratulations, proud, celebrate are commonly used for responding to the speaker's emotion of proud, and then the con the con the corresponding experience. So this is the first work. We mainly focus on empathetic response generation. However, the existing AI-based chatbot currently are limited to text-based conversation. Those system ignores the rich information containing in voice, such as intonation and nouns. So we believe the voice-based information can reveal more mental health conditions and signals, such as sadness or other emotional experiences, than text. And the voice communication is also associated with the stronger social bonds. So this is our future work. And the next work we focus on is the disease diagnosis using large language models and graph reasoning. And this work was collaborated with University of Wisconsin School of Medicine and Public Health, and also the Harvard Hospital and other universities from USA. So for this work, as we know, the process note, that is a common note type in the electronic health record, EHR, and the EHR also contains like the necessary details of medical billings, etc. And the process note contain both like subjective and objective information gathered by the care team, and it's updated daily and serves as the most viewed clinical document by providers. Especially the complexity of the process note increases when, for example, a patient is in the intensive care unit, the ICU. The information and cognitive overload occurs frequently based on this situation, with the more opportunities for misdiagnosis and medical errors. So uh, that will be very important if we could automatically generate a set of diagnosis problems in a process note based on the large language models or AI models. And it may assist providers in overcoming cognitive biases and heuristic or applied and apply evidence-based medicine by the information ceases to accurately understand a patient's condition. So this process may automatically reduce the effort in document review and also augment care during a time-intensive hospital event. So that's the motivation of our work, and we like to improve and generate the disease diagnosis based on the large language models and the graph reasoning. And for this work, we mainly use a public available dataset, which is called MIMIC3. And the full name of this dataset is the Medical Information Mart for Intensive Care. So that is the public available de-identified EHR data, having almost 60,000 hospital ICU admissions. And then we further annotate 10,000 assessment data required the doctor expert to annotate them. And then we use the concept extractor from QuickUMLs, which is a fast and lightweight Python package to identify all medical concepts and relationships in the text. And then we encode them into a common concept unit identify space, which is called CUI embeddings, based on the Unified Medical Language System. And here is the whole framework of our model. As I mentioned, we process the patient process note, the notes, and then we use the concept extractor to retrieve each medical concept, and then use the UML's knowledge graph to build our medical knowledge graph. And then we explore the disease diagnosis path by our graph model, and we try to identify several possible knowledge graph paths which could help us identify the possible disease or reasons. And after retrieve those useful and possible knowledge graph pathways, and we design our prompt templates, and we fuse the knowledge graph passes into those prompt templates, and then we generate our we decide our final prompt template, and then add some few short examples from the MIMIC3. We feed all of them. We feed all of them together into our large language models. So here we use the T5, GPT 3.5, etc. So we test those language models based on our prompt with the knowledge graph path. And finally, those large language models will generate the short disease diagnosis back to us, and then we will ask the physicians evaluate those large language models output based on our input node with or without knowledge graph pathways. So those are the whole framework and we focus on. And I'm very happy if you have any questions regarding these two works, and if feel free send me emails or look at my personal website. Thank you very much.
All right.